Good afternoon, everyone, and welcome to the Couchbase webinar today, From MongoDB to Couchbase, How to Make the Switch. My name's Allie, and I will be moderating the webinar today. Before I get started and pass things over to Shane, our presenter, I want to take care of a few housekeeping items. One, this session is being recorded, so you'll receive a link to the on-demand recording of the webinar as soon as it's done. Second, we encourage you to ask questions throughout the webinar. We have allotted a bunch of time at the end to make sure we answer all the questions that come in, so feel free to pop your question into the questions box that's on the left-hand side of your console. We've also made the slides from today's webinar available for you to download. You can go ahead and grab those from the resource folder. That's the green button at the bottom of your console, and you can download those at your convenience. And last, at the very end of the webinar, a super short survey will pop up asking for your feedback. So we would appreciate you letting us know what you thought as we take all this feedback to make all of our webinars even better. So with that, I'm excited to introduce Shane Johnson. Shane is our product marketing manager here at Couchbase. Unfortunately, Chris from Gannett had a last-minute emergency, so won't be able to attend the webinar, but since Shane and Chris have worked together so closely over the past few weeks on this webinar, Shane is the person who will be able to talk about Gannett today. So with that, I'm going to pass things over to Shane to get us kicked off.
Thank you, Allie, and welcome everyone to today's webinar. Just to give you a quick idea of the agenda, we're going to open with the good things about MongoDB, why enterprises may start with it, some of the challenges that they'll face as it moves into production and starts to have higher requirements. Then we're going to talk a little bit about why Gannett moved to Couchbase. So what were the specific challenges that they were facing around their requirements and what they needed to do. And then we'll do a little bit on kind of making the shift from Mongo to Couchbase. And we're talking about terminology, basic architecture, basic operations, kind of a one-to-one mapping to help with that transition. And then we will conclude with some more technical information on how Gannett actually went about replacing MongoDB with Couchbase. And of course, we'll save some time for Q&A at the end. So please do post your questions, and I will try to get to as many of them as I can. To give you a little bit about me, I've been with Couchbase for almost 2 years. Prior to that, I spent some time at Red Hat. So I'm still a big fan of Red Hat. I am as passionate about as open source as anyone, and mostly what I did there, as well as some consulting prior to Red Hat, was around distributed systems. So if you do have technical questions about distributed systems, in particular NoSQL and how they work, I'm happy to answer those questions as well. So we kind of have our standard slide on Couchbase here. Some of our example customers and how Couchbase Server can be used, but I wanted to take a moment to talk about Gannett since they couldn't join us today. So for those of you that may not be familiar, they are a $3.2 billion media giant. And so they own over 92 publications, including USA Today, and they have over 2,700 journalists. And so as we get a little bit farther down into the challenges they faced and how they went about migrating, I want to give you a little bit of context on that, and that all of these publications and all of these journalists, a few years back, they consolidated everything into an in-house content management system they call Presto. And that CMS was based on .NET, MongoDB, SQL Server, and included some Memcached as well. And so as a part of redoing the architecture to support better scalability, better performance, better availability, they migrated all three of those systems into Couchbase and moved to the likes of Python and Node.js. And so while we are going to focus today on the migration from Mongo to Couchbase, there's a great deal of information out there on how they migrated from SQL Server to Couchbase, as well as from Memcached to Couchbase. So hopefully that provides just a little bit of context on what Gannett was working on, the challenges they were facing, what they were trying to accomplish, and we will certainly get into more details on that. I want to start with MongoDB. It is really easy to get started. MongoDB has done a great job kind of championing NoSQL from the beginning. So it certainly played a critical role in helping NoSQL see the adoption and awareness that it has. A very large community and a very broad ecosystem. So there are lots of things to like there, and it's very easy to learn NoSQL through MongoDB, or to do your first POC, or to do your first small application with Mongo. But what we find is that it doesn't take too long before you start to run into some challenges in a production environment. Those are certainly going to be around scaling. You know, how efficient is it? How reliable is it? How complex is it? There are going to be some issues around availability. In particular, we're really talking about the type of availability that you can achieve when you have multiple data centers, or if you're deploying to multiple cloud regions or multiple availability zones. That level of availability, when it comes very critical in enterprise deployments, can be difficult to achieve. Performance, especially supporting many, many users. Can you continue to hit your performance targets? Caching, do you have to introduce a separate caching layer to maintain that performance, and what kind of complexity is that adding? And the last part is really just about the ability to manage it. Being a piece of software that can be complex to set up and maintain and scale, how much time and effort is required to keep it going. And so these are just a handful of some of the challenges that people may face, maybe not all of them, maybe some of them. And when we get a little bit farther, we'll talk about those that were applicable to Gannett and when they were considering their migration. And so we'll start with kind of the deployment topology. Those of you that are very familiar with Mongo might recognize this. Those of you that have only been evaluating it or taking a look at it, we'll go into this just a little bit here. There's a lot to install if you want to create a scalable sharded cluster. You have config servers, you have routers, and then you have each of those shards with a primary and, by default, I think most people have 2 secondaries. Could be more, as well as an arbiter to help, kind of elect new primaries if necessary. So the point isn't to spend too much time here, but just to highlight that there are a lot of different pieces, right? Those pieces have to be connected to each other, right? They also have to be deployed to the right hardware. So these could all run on different servers, or if you're striping them, you're going to have to ensure that secondaries aren't on the same server as the primary, or not even on the same server as each other. So there's a little bit to think about with that initial deployment, as well as the process of scaling. So when you do need to add extra capacity, you're going to have to create a whole new shard and configure that shard, add another router, add that to the original set. So there's a little bit of work to go on there. The other one is around availability. So there are different options for how you might have deployed MongoDB. One of the kind of the basic ones here is the idea that if all your primaries on one data center, your secondaries sit on the others. And so there is some degree of availability in that if the data center with the primaries fails, the secondaries on a different data center, they can be promoted to primary. But there's a gap there, right? There's some period of time where a new primary has to be elected. And so there's kind of a delay there. And if you get into it even more, depending on how fast you want to fail over, you could have issues around the routing. And when we talk a little bit more about Amazon, it starts to get a little bit complex. So if you have a requirement where failover should be instantaneous or seamless, it can be a little bit challenging in this scenario. Other ones that you could do is put different primaries in different data centers. So that is certainly a possibility. But ultimately, you're still going to end up with rights having to go to a primary. So if I'm a U.S. person who happens to be in EMEA, if my account is tied to a primary in the data center in North America, I still have to read and write to that data center, right? Or at the very least, I have to write to it. I could always read from a replica. So there's kind of a lot to consider when you want to do something globally, whether it's multiple data centers in the same country or maybe different regions across the world. It starts to get a little bit more challenging. The other issue can happen is simply the number of concurrent users. And so with a small number of concurrent clients, the performance difference, it could be marginal. It depends on your hardware, it depends on your setup. But as that load increases, MongoDB isn't going to be able to keep up for very long, right? So they can kind of support some increasing number of concurrent clients, but not for too long before the latency starts to spike pretty severely. So that can be an issue when people talk about performance and the challenges that they're facing. And the other one that we mentioned is just the ability to have a cache. And so it's been fairly popular for some time now for people to pair Redis with Mongo. And that's understandable. So Redis is a pretty solid cache. MongoDB is your database. And many people who start out before moving to something like Couchbase were in an environment where they had a database and a cache. It could be Oracle and Coherence. It could be Cassandra and Memcached. It could be Mongo and Redis. So those things are often paired together. But again, that just introduces another level of complexity and a little bit more management. So it's not just about managing your MongoDB environment, but you get to manage that Redis environment. And somewhere within your application, you're going to have to manage both and understand how to talk to both. And this is kind of an issue around management. And so what we're trying to get here with this particular example is that if you're running on fairly modern hardware where you have multiple sockets and you have multiple cores, right? In this particular example, 4 sockets, 18-core processor in each socket. So you have quite a few sockets available to you. If you kind of approach this from more of a default perspective, you might run a primary on one of these servers and a secondary on each of the other 2. But you start to have some issues there and that you're only using about a third of your resources. So you have all of these cores and all of this memory, but your application is essentially using just 1/3 of it. It's using just that one server. The other option is you can begin to stripe those. And so MongoDB queries are single-threaded. And you might realize that if I want my query to take advantage of more than just the one core out of the 72 that are on the service, then the next best bet is to simply install a lot more MongoDB nodes on that physical server. So in this example, you could certainly do that. But then again, you have to wonder, what is that like from a management perspective? So if we decide to do one shard per server, you're looking at 3 times the number of nodes. If you wanted to do 1 shard per core, you're looking at 72 times the number of nodes. So we have seen environments where, given a small number of physical servers, the ops people have to manage dozens, if not hundreds, of MongoDB instances. And like any distributed system, the more nodes you have, the more likely there is to be failure. So this can be pretty daunting. It can be effective, but it's really a question of management time and complexity. And so we'll take a moment here to talk about some of the drivers from Gannett moving from Mongo to Couchbase. Chris and I have had extensive chats about that, and we're very fortunate that he was able to share a great deal of information on what they were experiencing, what they were trying to work for, and how they went about it. So from the beginning, to be fair, they had already had some experience at Couchbase, and it went pretty well. Some of the issues around MongoDB kind of started as early as not really getting the operational support. So facing some of these challenges we just discussed, they weren't comfortable that they were going to be able to overcome them or get kind of the guidance they needed to overcome that. And so they kind of took a position that instead of having some stuff running Couchbase and some stuff running Mongo, perhaps they could just settle on one database to handle everything that they needed. Probably one of the more critical ones is around AWS. So Gannett is one of those many companies that is moving their infrastructure to the cloud, in this case Amazon. And because they have, as I mentioned, thousands of journalists, these journalists are all over the place. So they're in different cities, different states, different countries, what have you. And the point of view that they have on availability is that it is always available. right? So there can be no point in time where this CMS is not available. They have all these newspapers, all these journalists. There is no business hours, so to speak. It has to always be available. Yet at the same time, there is an understanding that things could fail. And so that's why within a particular region, they will deploy to multiple availability zones. And what they're looking for is that if they were currently active on one availability zone and it failed, they should be able to seamlessly and instantly fail over to a second availability zone. That was kind of one of the major requirements. The other one is that they might have two different journalists working on the same article, and those journalists could be in two different cities, two different regions, two different AZs, accessing two different sets of infrastructure. And the problems that they were having with Mongo is really the time and complexity of the failover. So certainly they could deploy Mongo with replication. They would put their secondaries on different AZs. Excuse me. But the process of failing over from the AZ running the primary to one of the two AZs running the secondary, A, was not instant or seamless, and B, was complex. And so they started writing lots of Python, doing kind of lots of workarounds, lots of custom logic that they were building to help them do that. And the other problem is that while they were capable of doing that to some degree, the primaries and secondaries were often out of sync. And so they kind of had some issues that with these Python scripts and with this custom code and logic, they could technically fail over to a different AZ when it might be potentially quite a bit behind or unacceptably behind primary. And so that was kind of a challenge for them. The other one, for those of you that might be running on Amazon in particular, might understand that there is often a need to rotate instances. And so from a cloud environment, you have an instance that you can run your software on, but Amazon recycles those instances, or those instances can move around to different servers or different locations, and so quite frequently they'll rotate those instances. They might discard some and rebuild them. They might actually rebuild a whole new cluster and then discard the previous cluster. So there is some maintenance around running NoSQL databases in the cloud, and what they're really looking at is that it should be really easy for us to replace nodes. We should be able to cycle out X number of instances from Amazon and cycle in Y number of instances in exchange. That should be pretty quick for us. Same thing for loading a new cluster. They had said that they had to write, again, a lot of Python scripts and extra work to add a new MongoDB cluster and load it with the old data. And so they wanted that to be more seamless and faster and easier. Also better performance and scalability. So there's not a whole lot to add here other than it was one of those things that they needed across their system. And then they did have some thoughts on the mean stack. And so their point of view, and I was talking about this, and I thought his response was great, is I asked him about the pros and cons, mean stack and moving to Couchbase, and he looked at it not necessarily in pros and cons, but in trade-offs, which I think was a great way to look at it. And so mean stack made things very simple. So their developers were able to get up and running with MongoDB very quickly, requiring very little work. But the trade-off there is that you have less control and less flexibility. So that stack is going to store the data the way it wants to, not necessarily the way you want to. It's going to want the application logic to be a certain way, not necessarily the way that you want it to be. And so as they matured, they started realizing that they're creating lots of workarounds, a lot of extra code. They're trying to substitute things. So it proved a little bit challenging to them, as they moved into production, and ultimately, again, had some issues scaling as well as they needed it to. And so we'll kind of go back to Mongo and Couchbase, and then as we get through some of these translations, we'll revisit Gannett, and we'll talk a little bit about how they actually went about moving from Mongo to Couchbase. So I won't go through all of these, but the basic idea is that they're both document databases. They both store documents together. They could either be different documents in their own groups, or you could have kind of a big group that stores all your documents. We tend to simply use the term bucket. That's how we organize data, is we bucket it. How granular that bucket is up to you. So you could store all your documents in the same bucket, or you might create a handful of buckets and each one stores similar documents. And from a topology point of view, we'll often talk about adding nodes because that's all it is. So you just add nodes as you scale. We don't have the concept of primaries and secondaries, let alone some of the extra things around arbiters and shards and routers and config servers and things like that. One thing I do see in here, which I'll have to fix later, is that what they call chunks, which is kind of a very small partition of data. We call those virtual buckets. So we do have that in common. So they have a database, we have a bucket. A database actually contains many, many chunks, and those chunks are distributed across the primaries. Our bucket has many, many virtual buckets, and we stripe those across all of our nodes. So there is that in common. If you talk about basic reading and writing, or CRUD operations, again, I'm using Java here for my examples, but they're fairly similar to what you would have seen in a MongoDB world. You have to connect to the cluster or to the database. In our case, you connect to a bucket. For them, you connect to a collection. We both work with kind of a document model, and we simply insert those, or we get them out. If there's any slight difference here, it's that Couchbase, in addition to having a query API, also has a key value API. So if we just want to get a document by an ID, it is as simple as get by that ID, as opposed to using a query and querying by that ID. So the net result is exactly the same, but there are a few subtle differences in how you go about doing it. Excuse me. If we look at querying as another example, if we start out with something pretty similar, where we just want to get something based on the value of a particular field, it's kind of pretty easy to parse that, especially from a MongoDB perspective, right? You have a JSON document, it just says type snacks. What we have is nickel, and our query language is based on SQL. So if you've seen SQL before, this is going to look very, very familiar to you. And from starting out with the most simplistic of queries, it probably looks a little bit shorter and a little bit more concise using MongoDB query document. But as we move to queries that are a little bit more sophisticated, there starts to be a little bit more differences here. So if you're very used to building MongoDB queries, there's going to be a little bit of a translation for you as you move kind of to writing your queries using SQL. But I think there is a benefit here in that SQL being a query language and being expressive is naturally very easy to read. So if you look on the right side, if you just read that to yourself, it makes sense immediately what we're trying to do. Versus on the left side, it starts to become a little bit more tricky to parse. If you're very, very well versed in the format of MongoDB query documents, it might not be too bad, but the readability here is definitely subjective. And certainly, as these get more complex, our queries start to look a little bit more concise. As some of you might know, in MongoDB 3.2, they added the lookup function, and that's kind of the equivalent of what we call nesting. And so certainly, if you want to get orders, but you want to find the line items, you can embed those line items into the orders document in the event that they're in other documents. They do something a little bit similar on the MongoDB side, where if a document has an ID or something in it, it can certainly go fetch a related document and embed it. And so look up next. They also have unwind. So if you have a JSON document with a lot of nested or embedded objects within it, you can kind of pull those out from a query point of view. We call that unnesting. And so we can kind of do the same thing. If there are, the kind of big differences from an application point of view, it's going to be things around inner joins. So in this particular example, an inner join has kind of an equality on either side. So if we want to join books and authors, but you might want to say the book category is science fiction, the author's country is the UK, that is an equality on both sides of that join. That you can't really accomplish in Mongo, right? So probably what you're going to do is you're going to issue your first query to get all the books. You're going to issue another query to get all the UK authors, and then you're going to have to iterate over those books. You're going to have to find the author, see if it's, if the author is found, then great, add it to the book. If you can't find the author, then pull the book from that collection. And hopefully after you're done with that, you'll finally have a list of books that are associated with authors. So a little bit more work there to get that done. But with a full-featured query language, it becomes a little bit more easier for you. You just have to express what you're trying to do. And then indexing. So Mongo and Couchbase both support a lot of the same types of indexes. You can do simple indexes, compound indexes, partial indexes, while not shown here, geospatial indexes. So there's a lot of flexibility on how you choose to index your data. So we have a couple examples here. These are essentially one-to-one. Again, if there's one thing that'll stand out, it's going to be that those index statements on the Couchbase side should look familiar to you if you've worked with relational databases in the past. It's kind of the same syntax. You just create an index on some bucket based on some fields. If it's a partial index, based on some particular criteria. So it should be fairly easy to translate from one to the other. And then deployment. Certainly this is where some of the differences are really going to begin to shine here. So if we were to look at an environment where we had 9 physical servers, from a Couchbase point of view, we would tell you to install 9 nodes. If there's one thing that Couchbase is very good at it, the more memory and the more cores you throw at it, the better it performs. So as hardware gets better and faster and cheaper, Couchbase is always able to take advantage of it. Coming from a MongoDB world, you're probably seeing environments where instead of having one physical server per node, you're probably striping those nodes across all of those physical servers. So any one server is probably running a primary, a secondary from a second shard, a secondary from a third shard, and maybe an arbiter from a fourth shard. So kind of to help from a failover point of view, you have all these shards, but those shards aren't deployed on the same server, right? Those shards are going to be striped across whatever servers you have, and you can run multiple shards per server that way. So just from a visual impact, certainly much easier, less complex. If we talk about scaling, where people said, hey, it's kind of complex to do this, this is a little bit about why, right? So if you did have a cluster with X number of shards and you realize, hey, I need more storage, I need more write capacity, essentially you have to add another shard. And that in itself means starting a bunch of nodes, initiating a replica set, adding those nodes to that replica set, the arbiter, and then finally adding that replica set as a shard. So there's quite a bit to do here. So if you were in a situation much like Gannett, where you're running on Amazon and you want to rotate these instances, which often means swapping out shards running on new AWS instances, there's quite a bit of work to do there. And again, for those guys, that meant writing more Python scripts. From a Couchbase server point of view, you simply add more nodes, right? So however many nodes you have, if you want to add more, start those nodes, add them, and rebalance the data. It really is that simple. And so for Gannett in particular, that meant they could rotate AWS instances very, very quickly. So if Amazon was about to drop them or move them or cycle them internally, these guys can very easily drop those nodes, add some new ones, rebalance the data. Caching, especially if you've come from a MongoDB and Redis background. Couchbase Server has its own internal cache. So we can trace our lineage back to the likes of memcached, and so within our database is its own object cache. And so we don't really need anyone to have a separate cache, right? As much memory as you can give Couchbase, Couchbase could use that memory to store objects and to improve read performance. So there is no need for the separate cache, and that is why enterprises like Gannett can not only migrate from Mongo to Couchbase, but they can also migrate memcached to Couchbase and consolidate their infrastructure with a single solution that can do both duties. And so in particular, Gannett, they're going to move forward with a Couchbase cluster that was assigned a lot of memory, in which case it can be as effective or more so than memcached, but also easier to manage. And then multiple data centers is another key thing to think about. So in this case, as I had before, with MongoDB and multiple centers, you do have different options. Put all the primaries on a single data center. You could certainly stripe those primaries across multiple data centers. But the idea here is that replication in MongoDB is one way. So it is from that primary to that secondary. So on the left, if you had your secondaries in data centers 2 and 3, all those writes go to the primaries on data center 1, and it can replicate data to 2 and 3. And that gives you the benefit, and you can read from each of those data centers. And so that's good. You have read locality. With Couchbase Server, we do bidirectional replication. And so applications can read everything and write everything to their closest data center. So if North America were to fail, in this particular example, it would not impact EMEA or APAC, right? They continue reading and writing everything to their local data center. If, for example, you had data center 2 failed, you could use a load balancer to reroute EMEA to North America or APAC. It would be up to you. So that's a little bit about the benefit that Gannett had, is that instead of having to manage the failover in MongoDB from one availability zone to the other, they could do it at the load balancing level. So because it's bidirectional replication, because it's memory-based, those data centers are almost always in sync or very close to being in sync. And you can use a load balancer to fail over instantly, right? So they don't have to write scripts for it. They don't have to write application logic for it. They can kind of move that up the stack more and kind of do it in a hardware point of view, which is what they're looking for. And the same thing about supporting users working on the same document. So in this example, someone from North America and someone from EMEA could technically be working on the same document, right? And those updates go both ways. So we'll talk a little bit about the physical process of how Gannett did it. They started with the mean stack. And so they kind of pulled out, in particular, some of the mean dependencies, some of the MongoDB dependencies. I think it says mean here, but I think what we're really talking about is they pulled out some of the Mongo dependencies from mean. And they chose to write adapters for Couchbase. And so for the physical migration of the data from MongoDB to Couchbase, they actually used that adapter. So they wrote an adapter for the application so that it could now read and write to Couchbase instead. They then reused some of that code. They kind of pulled it out a little bit and built a one-time tool that they could use to actually move the data over. And that was as simple as read something from Mongo, insert it into Couchbase. The only caveat there is that they did reshape the data a little bit. So kind of as we'd mentioned before, the way they were using the main stack is they were kind of letting mean control the data model. But they knew from kind of a data access point of view, so how they access the data, that it shouldn't necessarily be stored that way. And so before it was one big document. And for context, they have documents that represent workflows. So we're talking about publishing articles. That process has a workflow. And that was just one big document. But what they really wanted to get to was have one small document for the workflow and have it reference different documents that had details on each step of the workflow. So if you have a 5-step workflow, there's one document for the workflow itself, plus 5 other documents that represent each step in that workflow. That was a model that they felt was going to perform much better with the way their application accesses data. As they went about that, they kind of came up with key conventions and multi-get. So if they get this workflow document, it has a few steps in it. There's essentially an ID for each step. And so they grab those IDs, and they issue a multi-get, which is basically one request logically from the app into the Couchbase cluster to get all of those different steps and pull them back together. And that worked really well for them. One thing they are going to do going forward is start to replace those multi-gets with nickel queries. So they had a very solid key value strategy as a part of their initial migration, but kind of the second step as they embrace Couchbase is to also embrace the query language and to use that where possible. Excuse me. I did want to add one other thing here. And this is something that we found not only from Gannett, but from some of our other customers as well, is that with a document database that has a comprehensive query language and includes support for outer joins and inner joins and self joins, etc., the way you model data becomes a lot more flexible. And so from a relational world, you could have dozens, even hundreds of tables, maybe more, depending on how complex your application is. In kind of the old NoSQL world, it goes all the way to the other extreme where you have one big document. But what we're finding is the best combination of flexibility and performance is, kind of shades of gray in the middle. And so you might have a document that has some nested data, some embedded data, but where appropriate, references data in other documents, right? So it's kind of, it's not wholly denormalized, it's just partially denormalized. And the way that Gannett thought about it is we do natural, they called it natural links, or splitting data by domain. So if data was separate, like really logically, mentally separate, then we're going to put it into two different documents. But if it's related data, it logically should be grouped, it makes sense it should be grouped, then we would embed it. I think a good example, not necessarily related to Gannett, might be customer profiles and their addresses. So if a customer has a home address, a shipping address, a billing address, those things don't necessarily have to be stored in separate documents. They can just be stored within that customer document. But if you're looking at things like purchases, those purchases might reference the customer document. So it does give you a little bit more flexibility, and that's what they're taking advantage of well. I think on the one kind of counter argument, it wasn't all rosy. So as they did this process, the way they described it is that their developers said the Couchbase SDK is, in their terms, a low-level API. And that was probably, I think, true in that it does not provide the same high-level abstractions that you would find in the mean stack. We do have object-document mapping available for Node.js, but still, if you're in an environment where you're using something like mean or other very high-level abstractions that essentially hide Mongo from you or they hide the database from you, there's going to be a little bit of learning curve here because we have a very powerful SDK, but that SDK is very close to the database. So it kind of gives you very direct access to the database. So a little bit more learning, a little bit more work, to be fair. What they ended up doing to handle this trade-off is they created a library. And that library basically takes all the patterns that their developers were used to, that they liked, that they preferred, and it kind of wraps those patterns around the Couchbase SDK. So they could take advantage of the SDK to have very specific data access, but they can kind of wrap some abstractions above that SDK that work for them. So that's how they solve that problem. So a couple of things as we finish up here and get ready for QA. Especially in talking with Gannett, is really learning how to interact with the database, as opposed to letting scaffolding or some other code generation or abstraction sit in front of you. There is a lot to gain by using the API itself to get what you want. And again, from the data modeling point of view, I probably can't stress this enough, is that there's a lot of benefits to finding the right balance between embedding or referencing data. It's not really an either or. It just depends on how you access data. If it makes sense to have it all together in one document, that's great. If it makes sense to have it in separate documents, that's great. But adapt that model to meet your requirements. So don't build your application necessarily around the model, but give some flexibility in that model to better meet your application. And certainly adopting the query language. Nickel is extremely capable. It can do a lot of work for you, especially with respect to joins and key conventions, which is probably another topic for another day, but can be very helpful too. We do have services available to help with that migration. I'm not going to go into a great amount of detail here, but we do have a MongoDB acceleration package where we can send in people to work with you to look at, what are your use cases, what's the infrastructure look like, what's the data look like. Let's come up with a plan on how you can kind of begin to shift into Couchbase. Make sure that works for you, kind of go through a pilot all the way to functional and performance testing and support. So there's a lot here, so definitely feel free to reach out to us about that. But I do want to save some time to take questions.
Awesome. Thank you, Shane, for an excellent webinar. So as Shane mentioned, please submit your questions. Looks like we already have a ton, so we will do our best to get through them all in the remaining time we have. So it looks like there were actually a couple of questions, which I think you just touched on, Shane, around any adapters or any tools that we might have to make it easier to migrate from Mongo to Couchbase. So based on what you just talked about, is there anything more that you can add to that?
Yeah, so we don't have tools in the way of migrating the data in and of itself. We can certainly help you with that. The folks at Gannett, they really wanted to move towards using the SDK and having much more control of the data model. But as I mentioned before, although briefly, we've created an object document mapping framework called Ottoman that you can use with Node.js, which is much like Mongoose for Mongo. So that does provide a little bit of an attraction. And for those of you that want to get started a little bit faster, Ottoman is now GA and available for everyone to use, so feel free to take a look at that. But if it comes down to tools that can actually move the data, that's certainly not something we have off the shelf. If you have questions around moving from MongoDB queries to Nickel queries, that is certainly something we can help with. We can't necessarily automatically translate that for you, but we do have a white paper coming up pretty soon and some online resources around kind of learning to convert things into Nickel. So if that's something you're interested in, please feel free to let us know.
Great, thanks, Shane. All right, next question here is from Darren. Darren asks, what is the ingestion rate of Couchbase reading off a high-speed source such as Kafka? Can inserts go directly to an in-memory cache?
So that's a great question. So we do have Kafka support. So we integrate with Kafka both as a consumer and as a producer. So the first part of your question, the ingestion rate is extremely high. We've seen Couchbase deployed with Kafka in both directions. So some people will actually ingest directly into Couchbase, and then Couchbase streams into a Kafka queue. And we've seen it the other direction where people push stuff into a Kafka queue, and we kind of consume messages off that queue and put them into Couchbase. So the ingestion rate is very quickly, but that's because we have more of a memory-centric point of view. So all those incoming messages, we actually write them to memory, and then we can asynchronously write them to disk. And so that's how we can keep up with how we can keep up with Kafka in that type of situation. So the short answer is it ingests very, very quickly.
Awesome. Thank you, Shane. Next question here is around Couchbase nodes and specifically active replica. So what does it mean? What does that mean? Will it mean that the same node will act as both active and replica, or do we need two machines, one active and another for replica?
So that's a great question. I probably should add a slide in the future that's a little bit clearer on that. When I say a node is active plus replica, it is the first part of what you said. That means that each of our nodes holds all of the active data, or a subset for which it's the primary, and it holds replica data for other nodes as well. So it's doing double duty there. It handles all reads and writes only for the subset that it considers active. It holds the replica data only in the instance of a failover. So if one of those other nodes fails, it can kind of take on both the data it's doing as well as the data from that other node temporarily.
Great. I'm seeing a lot of questions coming in around specific use cases or maybe some issues that you're seeing when you're using Couchbase Server. We have a ton of questions coming in. So for those kinds of questions, we recommend that you use our forums, forums.couchbase.com. You can ask any question on the forum. All of our engineers, all of our evangelists are on those forums all day, every day, answering your questions, and we'll be better able to help you with your specific use cases. So if you have specific use case questions, use our forums. So next question here, which language works best with Couchbase, Java, PHP, C#, or Ruby on Rails?
Oh, that's a really good question. That might be a religious debate if you're to talk to a Java developer, a Rails developer, a PHP developer. What I can tell you is that probably the top 2 or 3, Java's going to sit at the top as far as popularity. So there's a lot of people using Java. We have a lot of .NET developers as well. So Couchbase in particular offers first-class support for .NET. We even integrate with Link for querying, so that's up there. Node.js kind of comes up there as well. I think in terms of popularity, those 3 are probably sitting around the top. PHP is certainly out there. We support most of the languages, but in terms of popularity, Java and .NET are number 1 and number 2.
Great. Next question here. Can you talk a little bit about the installation process of Couchbase versus Mongo and what the differences are between the 2?
Yeah, so I'll talk about it briefly. From a Couchbase point of view, you just download the software. You install it. You go through a fairly short install process. It's kind of the usual pick an admin, username and password, specify how much memory and storage you want to use. If you can use the default bucket or create a new one if you want. So it's kind of a little step-by-step process through the user interface to install it. Going forward from that, you just do more. As you want to create a cluster, you would just start more nodes. And then you go back into the admin interface, and there's a little spot in there where it says, add nodes to your cluster. You give it the IP address of those new nodes. They will join that cluster, and once they've joined, there's a rebalance button. You click that, the data is rebalanced, and then you have your cluster is operational. So you don't install different things per se. You just install the same thing over and over. And as those new nodes come online, you simply add them to your cluster via the UI. There's also REST services and command line interfaces and things like that, but it's probably easiest to just do it straight from the UI.
Cool. Next question here from Daniel. How does Couchbase actually rebalance the data, and how does the application identify which node stores which data it needs?
So that's a great question. I'm going to skip the rebalancing part. So I think at least from, not an internal point, but from an outside of it, we given a bucket of data, that bucket is carved into 1,024 V buckets. These are kind of the equivalent to chunks in MongoDB. And so a cluster kind of distributes these V buckets across the nodes. If you add nodes or remove nodes and you rebalance data, what's really happening is you're moving some of those V buckets around until the data is evenly split. As far as the second part of your question, we use topology-aware clients. So when you get the client and you connect to a cluster, you provide it with one or more IP addresses of some nodes in your cluster. Whichever one it connects to, its response is essentially kind of I forget what we call it, probably a V bucket map. But essentially what comes back is some information that tells it which nodes have which V buckets. And so I'll try to make this really quick so we can get to more questions. Essentially, if you want to put in a document and the ID is Shane, that text, that string, is hashed. to a value. And let's just pretend, say it hashes out to 100. The client then says, oh, which V bucket does 100 fall into? And so it kind of goes through and says, oh, this V bucket handles the range 200, 0 to 400. So it must fall in that V bucket. Well, which node owns that V bucket? Oh, it's node 2. All right, I'm going to go get that data from node 2. So hopefully that explains it. It's kind of, there's a little bit there, but the idea is that our clients are smart and they're always aware of how many nodes are active and what V buckets are owned by what nodes. I hope that helps.
Great, thank you, Shane. The next question here from Anil. MongoDB, to spread awareness on its technology, has free online courses. Does Couchbase offer any?
We do as well. I believe it's training.couchbase.com, and I think there's going to be a tab that says free online training, and there are a handful of courses there to help you get started. So please do try it and let us know what you think.
Agreed. Thank you, Shane, for pointing that out. So next question, there are actually several questions around Nickel. Maybe just a quick, what is Nickel high level for those who aren't familiar with what Nickel is and how it's kind of a big differentiator between Couchbase and Mongo.
Sure. So Nickel is our query language, and it is, think of it as something that extends SQL. So at a very high level, when you want to query data, you're going to say select some fields that you want to get from some buckets that have those documents where certain fields have certain values. You can combine, get me all the customers in this bucket, join them to their purchases in this other bucket, group by, order by, sort by. So if you have a SQL background, it's going to look just like SQL to you. The only difference is that we're going to add a few extra terms in there, or keywords, that help you query JSON. And so we can say select, customer.address.city from some documents. You can nest data or, self-join. So the easiest way I can say it is just that it is SQL, but for JSON.
Perfect. Next question here from Shyam. He asks, and I think you touched on this earlier in the webinar, but are there any benchmark reports and or architecture docs available for public consumption?
So there are. There's certainly, you're going to find plenty of benchmarks, both from us and from Mongo and probably from other NoSQL databases. So there's going to be plenty of benchmarks. I have to leave it to you to look at them and kind of determine for yourself which ones are providing relevant information. What we do have in particular that I think might be really useful is we do have an architecture document that looks very specifically at MongoDB architecture and Couchbase architecture. So you can then find that on Couchbase.com as well. So I would certainly encourage you to, you can look at some of the recent benchmarks and check out that architecture white paper. It's pretty thorough and kind of long, but it's really going to give you a lot of valuable information.
Great. Next question here. How does Couchbase achieve high availability?
Right. So within a cluster, as I kind of hinted at before, you specify the number of replicas. So if you insert my user profile to node 1, that node will take a copy of my profile and it's going to put it on node 2 and node 3, which is what we called the replicas earlier. So data is replicated and sits on multiple nodes, so in the event that one of those fails, the other one can kind of take over and still serve it. And then we also do replication between clusters as well. So for really ultra-high availability environments, we can bidirectionally stream writes between multiple clusters so that you can kind of instantly switch from one to the other.
Great. Next question. Does Couchbase handle network partitions, and if so, how?
Yeah, that's a really great question, too. By default, if you have a cluster of nodes and one of them is partitioned out, that data becomes unavailable. So in a CAP model, for those of you who are familiar with it, the idea is that if there is a partition, you choose between consistency and availability. By default, we choose consistency. Within a period of time, if that node can't get itself back into the cluster, it will be failed over, and one of the other nodes will take over. However, from an application point of view, if availability is your primary concern, we have options such as read replica, which allows you to read from any node available that might have the data. You just have to, decide for yourself how to balance consistency versus performance. So, excuse me, if consistency is not a problem, then you can do read replica, and you'll always be able to find that data. If consistency, is a big issue for you, then you might have to look at the impact on your writes, because in order to handle that, when you write some data into the cluster, you're going to have to synchronously replicate that to other nodes before that write finishes. So it might take a little bit longer to make sure the data is replicated before your write's complete. But the benefit is if something fails later, you can read from those replicas and be confident that the data is consistent. So this is a topic in and of itself, but hopefully that short answer helped you.
Great. Thank you, Shane. The next question, how do you recover from a full cluster failure in Couchbase?
So that's a good question. A couple ways to go about that. One of them was we do have backup restore policies. And there's quite a bit there from one-time backups, cumulative backups, incremental backups. So there are a lot of options available from a disaster recovery standpoint. The one that is most useful, and this is a great question because this is the approach that Gannett takes, as we talked about, they might cycle out nodes, and that process might mean that while a cluster is running, they want to spin up a new one so that they can discard the old one. And the reason I mention that is that we can populate a cluster using XDCR, which is cross-data center replication. So if you have a cluster up, you can have another cluster. You can constantly, you can actually use that cluster to populate the other one. So that's another way to kind of handle failover. So there's lots of different paths there. Feel free to check out the docs for much more information that I can give you here.
Great. Looks like a few questions have come in around Couchbase's support of transactions. Can you talk a little bit about that?
I can. So the short answer is that Couchbase handles transactions the same way as Mongo or just about any other NoSQL database, which is we don't do multi-write transactions. So a single write, if you're inserting a document, that can more or less be ACID, right? It's going to be atomic, it's going to be isolated, it's going to be durable. Consistency is less appropriate in a document database world or a NoSQL database world, kind of because we're schemaless and we kind of move away from those schema definitions. But single writes, you can be confident in. Multi-writes, we don't support at this time.
Great, thank you, Shane. So I'm going to take one more question given the time. If we don't get to your question today, I know there's a ton, then we will make sure someone follows up from our team and gets those questions answered for you. And of course, like I mentioned earlier, any specific use case or technology questions, feel free to use forums.couchbase.com, where you will get an answer from either someone here or from the community. So the last question we'll take, how costly is cross-data center replication compared to what Mongo has?
So I'm not entirely sure what you mean by costly, but I'll try to take this one on. XDCR and Couchbase, is very low latency and it's really fast. So we look at it as another memory-to-memory path that we're doing. So as soon as that data is written to memory on a cluster, it is immediately queued up to be streamed to memory on another cluster. This data is ultimately going to be written down to disk, but from a performance impact, we're not going to wait to write it to disk to replicate it to another data center. We also have a few options in there, such as partial replication. So if you have a central data center, per se, where you have all of your data, and then you have a bunch of data centers that handle certain subsets of data, you can choose to replicate only a little bit of it to each data center. So there's probably a little bit more to talk about on this topic, and hopefully maybe that's a good one for another webinar. But XDCR is, it's very fast, it's very capable, highly configurable. There's a lot you can do with it. I hope that helps to answer your question a little bit.
Cool. So with that, it is the top of the hour. We appreciate everyone who stuck with us for the entire presentation. We hope you learned a bunch. Just a few reminders, if you do want a copy of the slides, they're available in the resource folder. That's that green button at the bottom of the console. We did record this webinar as well, so you'll receive a link to the recording as soon as it's available in your email inboxes. And last, like I mentioned at the beginning of the webinar, a super short survey will pop up as soon as the webinar is over. So we would appreciate you giving us your feedback and letting us know what you thought. So with that, thank you, Shane, for an excellent presentation. I hope everyone learned a lot, and thank you everyone for attending, and we will see you at the next Couchbase webinar.